We can do it. Yes, we can. We can change things throughout the land. But we all must lend a hand. We can do it. Oh, yes, we can. Oh, your neighbor over there, a bit bewildered, but he cares.
I'm Devon Hildreth. Our talk today is part of our series, Changing Our World. I'm delighted to introduce Susan Murcott to you. She is a scholar who believes in translating her science into the real world. Her life has been dedicated to providing safe water to people around the globe. Susan is a lecturer at MIT D-Lab, which stands for Development Through Discovery, Design, and Dissemination. She teaches classes on water, health and hygiene, and water and climate change. She also leads student teams to international destinations for research projects. And she's a founder in 2005 of an NGO, Pure Home Water, focusing on safe water for low-income communities without centralized water purification systems. Susan will be reflecting on her journey from cleaning up Boston Harbor to building a factory in Ghana that produces water filters. Her exceptional dedication to safe water for all resulted in a shout-out from Matt Damon at a recent MIT commencement. Welcome, Susan, with many thanks for sharing your experience with us.
Thank you so much, Devon. Lovely introduction. So I'm very happy to have this opportunity to share my work on safe water around the world. There is a distinction we can be making between the water-rich who have safe water in the world and the water-poor who have unsafe water. The water-poor are not exclusively in low-income countries. We've learned during the Houston flooding, in not just Houston but throughout southeastern Texas, that there is tremendous poverty in parts of Texas that pre-existed the flooding and that is exacerbated by the conditions of flooding. And that is the case that in many emerging economies such as China or Brazil or India, that there are there's increasing wealth on the one hand, but there's also tremendous poverty as well in those emerging economies, not just in the lowest income countries. But my work has been targeted on the water poor and also on what we would describe as the sanitation poor. Maybe some of you have seen Slumdog Millionaire, and the picture I show is from the slums of Mumbai, where you see the latrines that the slum dwellers use for defecation, but you also see children swimming in the pool of water that is wastewater from these latrines. That's unimaginable to those of us who are from a piped water world or who are used to flushing our toilets and take that for granted. This whole field that I work in is called public health engineering. And public health engineering is basically the application of fundamentals in chemistry, biology, physics, mathematics, engineering, sustainability, economics, and social sciences to protect human health and the environment. And the field has its origins in a school of health officers. It was founded at MIT and Harvard in 1913. So it's not that long ago. You know, my grandparents were born in the 1890s. So this school of public health, which would have been something that was coming into existence when they were young adults. And at that time, in the turn of the century and also in the 19th century, the field was called sanitary engineering. And today, we refer to this work that I do, this field, as WASH. WASH stands for water, sanitation, hygiene. All right, because it's those suite of activities that enable us to help prevent infectious diseases. I mentioned my grandparents' generation. My grandmother, at 16, as a student at Beverly High School, contracted polio. Polio is a waterborne and foodborne. It's an infectious disease. It's a viral. Polio is a virus. That was a huge scare in that era because it was before vaccinations for polio or many other diseases existed. So I mention that because we take for granted a certain level of that we don't get smallpox, that we don't get polio today, where infectious diseases like polio like cholera, like typhoid, which used to be scourges in our own country 100 and several hundred years ago, don't exist in our existence now. At the international level, there has been, since the 1980s actually, efforts to address global poverty, broadly speaking, including specific goals and targets to address water and sanitation. And the previous 15 years, from the year 2000 to 2015, that's been done under the rubric of Millennial Development Goals. And one of those goals was to reduce by half the proportion of people who lack access to improved water and sanitation. So my own work and that of my students has been under that rubric of the UN's goal, which has been agreed to by all the countries of the world. There was good progress made during that 15-year period on the water side, but sort of suboptimal progress, I guess you could say, on the sanitation side. In an effort to continue the work of reducing poverty, because it's definitely not done yet, there's a new set of goals that will be operating going forward from 2016 to 2030. And those are called the Sustainable Development Goals. And again, one of those goals is for clean water and sanitation. It's a somewhat more complicated sort of conceptualization because the problem is actually quite complex. On the water side, the goal is to now achieve universal access to basic services. There's a target by 2030 to ensure that men and women, in particular the poor and vulnerable, have equal access to basic services. So that's actually before we get even to basic drinking water and sanitation. And then specifically on water, by 2030 achieve universal and equitable access to what they call safe and affordable drinking water. And on the sanitation side, it is to end open defecation and to have safely managed sanitation. Then that leads to the question, how many people in the world currently lack safely managed drinking water services, under this new UN goal? And the answer to that question, does anybody want to guess? 2 billion, that's perfect. He's related to me. So yes, the answer is 2.1 billion people, and that represents 29%, almost a third of the people in the world. So again, that's sort of shocking to those of us who've had piped water and can turn on the tap or flush the toilet throughout our lives, as we of the middle class had. And then how many people lack safely managed sanitation services? Anyone want to guess that?
4 billion.
Yeah, okay, you guys have done your homework. So it's 4.4 billion people, and that's 60% of the world's population. So that's kind of hard to get your head around, isn't it? That many people don't have even basic sanitation. And then the third question, because we're looking at that WASH concept, that acronym, water, sanitation, and the third is hygiene. How many people have basic hand washing facilities with soap and water on the premises? And you can imagine the reason we care about that is because if you want to break the transmission of infectious diseases, one of the key simple things you can do is wash your hands with soap and water, especially after you defecate or change the diapers or clean an infant, you're preparing food, so forth. So the answer there is we don't know. We don't have global data yet. We'll be putting that data together over the next 15 years. What we do know is that we have some regional data, and to give one of the less successful examples, sub-Saharan Africa, 85% of people don't have a hygiene facility, a hand washing facility with soap and water. All right, so that's sort of our background. And then I will talk a bit about how I got into this field. I was very fortunate as an undergraduate student at MIT to connect with a beloved mentor and professor named Donald Harleman, who was quite well along in his career and had in fact been the head of the Civil and Environmental Engineering Department at one stage. And he had, in his decades of work at MIT, every 10 years or so would have a sabbatical and would kind of reinvent himself. And in the last 10 or 15 years of his career, he was working on the Boston Harbor cleanup. So my work with him began because he taught a course called wastewater treatment or wastewater engineering. He and I worked together, as well as some other students, on an innovation for the Boston Harbor cleanup, Deer Island. We were successful in demonstrating that in a pilot plant at Deer Island, but it was not ultimately incorporated into the final design. And I think I played a role in influencing him after 1992, when I graduated, to take this innovation to megacities around the world. And that's in fact what we did, is that he and I worked together in a number of megacities. And I should say that you can imagine that if 60% of people in the world don't have safely managed sanitation, then a number of megacities in the developing world don't have any sanitation facilities at all. They don't have any wastewater treatment. So, for example, Mexico City in 1992 and 93, when I worked there, had no wastewater treatment. They had a sewerage system that would direct the sewerage from, say, a neighborhood or an industry into it was called the Grand Canal, a major canal that ran through the city. And essentially it was like a river of sewage that ran through the city and ran out to the neighboring state of Hidalgo, where peasant farmers used the wastewater for irrigation, agriculture in a very dry area. So it was essential to them. It also had nutrients in it, but it was unsafe to be in physical contact with. And so our job was to demonstrate that our innovation in wastewater treatment could treat that waste so that the pathogens, the disease-causing organisms, would enable the workers to be safe. All right. So that was one of our first projects. But I'm using it to illustrate the fact that megacities had no wastewater treatment, in that case Mexico City, or other cities that I worked in. Sao Paulo had about 33% of its wastewater treatment, or Beijing was another city I worked in that period, had about 25%. This was long before they held the Olympics, when they built a lot of wastewater treatment plants. This was again in the 90s. So that was where my career began, and I spent about a decade on innovations in wastewater treatment. I should say that, yeah.
Did those megacities invite you in?
Yes, yes. So I was a young professional, and my professor was at the end of his career. The year I graduated, he became an emeritus professor. And we decided to work together, and he had a lifetime of contacts, basically graduate students who'd gone on to greatness around the world. And so he had contacts in many places around the world. And I had an eagerness to take the innovation that we were working on together and to demonstrate it. And so my job was basically to set up either at a bench scale, which would be like on a laboratory bench, or in a pilot scale, which would be in a small tank, maybe the size of this room. Or even at a full scale, I did an experiment on the city of Budapest, where all the wastewater that came to this one location in Budapest was directed into two trains, an experimental train, which was with our treatment, and the way that it was normally being treated, and to compare the two. And so I ran that experiment for the city of Budapest. So that was the kind of work that I was doing, and Professor Harmon set up those contacts, and I lugged the equipment all over the world and set them up. Yeah, that's what I did. So after the work in megacity wastewater, I had my first opportunities to do drinking water work as well. Water engineering and wastewater engineering are related. It happened that I'd cut my teeth and got my experience on the wastewater side, and so that's where my opportunities were first arising. But when I had my first opportunities finally to do some water projects, one was in Myanmar with some doctors from Boston, and a second one, that was in 1997, and a second in 1998 was in Nepal as a guest invited to a Women in Water conference. And in both of those instances, I was confronted with rural peasant farmers who had unsafe situations, and they were looking for the knowledge of how to treat their water, but also not just the knowledge of how to do that, but something that was affordable to people who were basically $1 a day people, earning $1 a day or so. And so the kinds of systems that you and I are the beneficiaries of, like we drink water from the MWRA, Boston's Massachusetts Water Resources Authority, and we flush our toilets and it goes to the Deer Island wastewater treatment plant. The water treatment plant was upgraded in the 1990s to a cost of $1 billion for 2.5 million people. And the wastewater side was a $4 billion project. So these cities like Mexico City or Kathmandu or rural Myanmar are not going to be able to afford these kinds of systems in our lifetimes. And so it raised the question to me as a young engineer eager to work in international development, how do we design simpler systems that are affordable, especially to the people, to the bottom billion or the bottom 2 billion or the bottom 4 billion. And those systems would need to be, in my opinion, locally produced, simple, easy to use, affordable, all right? And so that opened up a whole new sphere of engineering, which is development focused, all right? And D-Lab is a center of that kind of development activity, all right? That's how I wound up there. So in my career since, I have been focused on designing solutions for the bottom billion, let's say, and it's taken me and my students to approximately 20 countries over these years. So that's fast forward to 2005, and in that period from Myanmar and Nepal till 2005, I had the opportunity with students in supervising those students' master's projects to experiment with lots of different ideas. Some of them were our own innovations, and some of them were that we, in traveling the world, sought out what local people were doing and how we could enhance that or improve, and make it better. So I could tell lots of stories, like for example, we found a ceramic pot filter in Nicaragua that was being produced by artisans, ka-chunk, ka-chunk, one at a time, all right? But then there was a hurricane called Mitch in 1998 in Central America, and they needed thousands of these ceramic filters in order to address the disaster of the hurricane. And two colleagues of mine, Manny Hernandez and Ron Rivera, started the first factory in Nicaragua to make these ceramic pot filters. And Ron made it his life's work to disseminate these filters to any ceramicists in any part of the world. If they'd pay his plane ticket to come there, he would show them how to go from making ceramic wares to making ceramic filters, which is not intuitive to a ceramicist. It's a different process. Ron loved my work and my students and always wanted to go any country in the world that I was going to build a factory there. And I thought, oh my God, a factory, what a big responsibility. I don't know that I could do my work and be part of managing a factory as well. So it came to pass that Ron had his dream of building 100 factories in 100 countries in his lifetime, and he made it to 30 factories and died of malaria building his 30th factory in Nigeria. And subsequent to that, I and Manny Hernandez and others decided to build a factory, partly in his honor, partly in my dad's honor, who was a factory manager my dad's factory made health products. And here we have pictures of the factory, which employs 25 people in the poorest part of northern Ghana, and that's called the Northern Region. The regional capital is called Tamale, and we produce about 300 filters a month, and I'm happy to report that after some years we're breaking even, finally, and expanding our work in the coming year to try to do more promotion in the big cities of the south of Ghana. So you can think of Ghana as being about the size of the state of New York, and the capital, Accra, is about where New York City is, let's say, and then where we are is like going to to Montreal or Toronto or Rochester, kind of clear across the state. So we're seeking to sell our filters in Accra, in the capital, in the coming year, which we haven't had the capacity to do. It's a different universe down there. The impact of the ceramic pot filter factory has been twofold. Of course, our main focus of Pure Home Water has been to reach the people most in need of safe water, and our second purpose has been to become financially and locally self-sustaining. And in terms of the numbers that we've reached about 100,000 people in northern Ghana out of a population of about 3 million, most of whom need safe water in the north. And I should say that overwhelming numbers also need sanitation, and that's another story for another day, but we've done some work in public facilities in our communities. And what I've mentioned already is that we have been able to begin to break even with our work in the factory. To that extent, we are meeting our second goal of becoming financially and locally self-sustaining.
Hi, my name is Ron Rivera. I work for an organization called Potters for Peace. We train potters in third world countries around the world to make small enterprises. This is a ceramic weapon of mass bacterial destruction. You put dirty water in, like this, gray water that many communities still drink, and it comes out crystal clear. We use local clays. We work with only local potters. So the women you see here are already potters. We teach them how to process the clay. We teach them how to process burnout material that could be sawdust. In this case, it's milled peanut husks. The most difficult part of working with them is the transfer of technology with potters is to keep formulas, because if you change the formula, you change the filtration rate, and then it won't remove bacteria. The pore size of these filters here range from 6 micron down to 0.2 micron. Most bacteria, or all bacteria, are about 3 micron. So they simply do not fit, and they die in the filter.
Ron Rivera, you are living for quite a few years in Nicaragua.
In 1980,
the Inter-American Bank financed a study that was carried out by ICAITI, the Central American Institute for Industrial Technology, to evaluate 10 water filters. And the indicators for that evaluation was that the water filters could be produced locally, and it would remove microbiological contaminants, and it could be made by local artisans. Those 10 filters were evaluated, and none of them really passed the test. The chief of that evaluation team was Mr. Fernando Mazariegos, a Guatemalan, who decided to continue to experiment. And he did a lot of readings on other types of filters, including the famous Swiss Catadine, and found that the better filters, the better ceramic filters made in Europe, were coated with something called colloidal silver. He decided to coat his filter, or the locally made filter, with colloidal silver, and it worked. So he started coating them, and it became a success, and I was trained also. Since then, since I'm a potter and a sociologist, I found that it was an effective tool against diarrhea and against microbiological diseases. We continue to promote this.
Very briefly mentioned the work of the ceramic pot filter factory. An equally long-term commitment has been in Nepal to the well-being of friends and colleagues and associates there. And there's a story to be told in the arsenic in drinking water in Nepal and also around the world that I haven't told yet. And in part 2, I was also going to highlight some of the work of my students and what they're doing.
Many thanks, Susan, for sharing part 1 of your fascinating journey with us. We appreciate it very much.
I've really enjoyed it.
Cause an idea, whose time has come, cannot be stopped by anyone. Plant your seeds in fertile ground. There ain't nothing gonna keep it down. Oh, we can do it. Yes, we can. We can change things throughout the land. But we all must lend a hand. We can do it. Oh, yes, we can.